When you think of Angkor Wat, what comes to mind? Probably this epic, eternal monument, right? A breathtaking city of stone that's been standing for nearly 1,000 years. It just feels permanent.
I mean, its towers stretch up to the sky. The galleries seem to go on forever. Every single detail just screams genius. It feels so incredibly solid, just unshakable, as if it were carved right out of the Earth's bedrock.
But here's the wild part. It isn't. The shocking truth is that this whole colossal city is actually sitting on loose, sandy ground, a foundation that, by all rights, should have just given way centuries ago.
So what gives? That is the central mystery of Angkor. It's not a question of if it was built to last, but how. How in the world does this mountain of stone stay afloat on a bed of sand? Well, the answer is a stunning feat of engineering. And right now, that brilliant solution is facing its greatest threat ever.
Okay, so let's dive into this. To really get our heads around the solution, we first have to understand the incredible geological challenge the Khmer engineers were staring down. So, the ground underneath Angkor is basically a giant sponge. And as long as that sponge is totally saturated with water, it stays firm, it stays stable, and it can easily hold up the immense weight of the temples. But if that water drains away, if the local water table drops, that sponge dries out, it shrinks, and the ground starts to sink. For the foundations of Angkor, that would be, well, catastrophic.
So how did they solve this massive problem? Well, the Khmer engineers knew their environment inside and out. Their solution wasn't to try and fight the geology. Instead, they decided to master it, using the one resource they had tons of: water.
It all starts right here, in the headwaters of the Siem Reap River. This was the source, the lifeblood that fed what was arguably the most sophisticated water management system in the entire pre-industrial world. And they controlled that lifeblood with just incredible precision. They didn't just let the river flow wherever it wanted. No, they engineered this amazingly complex network of canals, weirs, moats, and these huge man-made reservoirs called barays to manage and store every single drop of monsoon rain.
You can think of this whole setup as the circulatory system of the empire. The giant reservoirs stored water for the dry season. The canals moved it where it needed to go. The weirs directed the flow. And the moats around the temples, they were like the final line of defense, keeping everything stable.
And just to give you an idea of the sheer scale we're talking about, look at this number. 56 million cubic meters. That's the storage capacity of just one of the reservoirs, the West Baray. To put that into perspective, that's enough water to fill over 22,000 Olympic-sized swimming pools.
So, and this is the crucial point, all of this, the moats, the canals, the immense reservoirs, it wasn't just for farming or for looks. It was a city-scale structural support system. Its main job was to keep that giant sponge of sandy soil permanently soaked, making sure the ground under the temples stayed strong and stable. This is what has kept Angkor standing all these years.
But that ancient, really delicate balance is now under threat from two powerful modern forces. One is acting on the land, and the other is acting on the sky. So on the ground, the watershed that feeds the whole system is dealing with rampant deforestation, and that completely changes how the land absorbs and holds on to water. And then up in the atmosphere, climate change is bringing hotter temperatures and, the real killer for Angkor, less rainfall to replenish everything. The scale of this deforestation is just staggering. In the last 30 years alone, that watershed has lost over a third of its forest cover. That's a huge change to the very landscape that was designed to be the source of Angkor's stability.
And this brings us to some really crucial science. Researchers knew these threats were real, but they needed to figure out which one is actually the bigger danger. And more importantly, is there a tipping point? As the study's authors put it, the stakes really couldn't be higher. Understanding what's going to happen to Angkor's water supply is pretty much the same thing as understanding what's going to happen to Angkor itself. So what they did was build a powerful digital twin of the entire watershed. Then they ran 30 different what-if scenarios, tweaking the amount of forest cover and rainfall to see how the system would react. They were literally hunting for the breaking point, that threshold where the water supply just can't keep up anymore.
And what they found was a really stark and urgent warning. It turns out the system is way more fragile than we knew, and the biggest danger comes from one single overwhelming threat.
Now, while both deforestation and less rain were definitely harmful, the computer model showed that the impact of one of them was an order of magnitude more severe than the other.
And the difference is pretty stark. Look, losing forest cover definitely hurts the system. There's no doubt about it. It messes with groundwater and the amount of water available in the dry season. But the effect of reduced rainfall is dramatically worse. It is the single biggest threat to the water that's keeping Angkor stable.
And this is the critical tipping point they discovered, a sustained reduction of just 10 to 20% in the average annual rainfall. That's all it takes. That's enough to put the entire ancient water management system under severe stress, threatening its very ability to keep the ground saturated and the temple standing.
This research really transforms our whole understanding of how to protect Angkor Wat. It shifts the focus from, say, a local land management problem to a global atmospheric one.
So let's just recap the big takeaways. Angkor's survival depends on its foundation, that sandy sponge that has to stay wet. The ancient Khmer mastered this with a brilliant water system. But today, that system is threatened most by climate change-induced drought, and the margin for error is frighteningly small.
You know, the builders of Angkor engineered a solution to their local environment that has lasted for centuries. The challenge for us is that the biggest threat to their creation isn't local anymore, it's global. Protecting this shared treasure of human history now depends not just on managing a single watershed, but on managing the climate of an entire planet.